This question asks us to show how a three-step protecting group strategy could be used to synthesize this product from the given starting material. Let's talk about why we even need a protecting group first. Our key reaction is going to be the reaction of the acetylide anion with the alkyl halide to extend the carbon chain and form the carbon-carbon bond. The acetylide anion, however, is a strong base and will react with the alcohol, deprotonating the alcohol, ruining our base, and not doing the desired substitution reaction. So we need to protect the alcohol so we can do the SN2 reaction, and then we can deprotect the alcohol. So the first step is going to be protecting the alcohol. So we can use a silyl ether protecting group. You can use whichever one you like. I'll use triethyl silyl chloride. Doesn't really matter what the 3R groups are. Any one will work. And then we'll use a proton sponge like triethylamine. That will protect the alcohol as the silyl ether. Now that the alcohol is protected as a silyl ether, there's no acidic proton anymore. So when we react this with the acetylide anion, there's no acidic hydrogen to ruin this reaction. So now we can react this molecule with the acetylide anion in a SN2 solvent like THF. That will form our key carbon-carbon bond. Now that we've formed the key carbon-carbon bond that we want to form, we need to deprotect the alcohol and bring it back to the OH group, and we can do that with tetrabutyl ammonium fluoride. Using water as a solvent to reprotonate the oxygen, we can get our final product. This three-step protecting group strategy will allow us to form this product from this alcohol in 3 steps.